Bismillahirrahmanirrahim. My name is Muhammad Said and my program is BS Biochemistry and my ID is 002 presented to Sir Dr. Hammad Majeed. So today my presentation topic is kinds of solid content solids and its example. Major kind of solids, there are two major kind of solids, crystalline and amorphous solids. Packing of sphere in crystalline solids, types of packing in which I will explain, uh, cubic and body center cubic, hexagonal closest and cubic closest. So next I will explain types of unit cell and types of crystalline solids and structure of ionic solids. So next, first of all, what is solid? A solid is a state of matter characterized by particles arranged such that their shape and volume are relatively steady. For example, the matter with a defined shape and volume is solid. There are many examples: iron bar, a chunk of aluminium metal, or any metal at room temperature except mercury, diamond, and most other crystals, sand, rock, glass, and coins. So major kind of solid, two major kind of solids. First of all, I will explain crystalline solids. A crystalline solid has flat faces and distinct angle. These regular macroscopic features reflect a similarly ordered arrangement of particles at atomic level. For example, amethyst. So here is show the structure of crystalline solids, and it show they are flat faces and parallel to each other, bond in the crystalline solids. So next one is second type of solid is amorphous solid. An amorphous solid has a disordered arrangement of its constituent particle, for example rubber and glass. Here is structure show that their particle are connected, disorderly arrangement. So next one is packing of sphere in crystalline solids. Types of packing in which simple cubic packing, body center cubic packing, hexagonal closest packing, cubic closest packing, and face center cubic packing in which unit cell. So simple cubic packing first. Take a large number of uniformly sized marble and arrange them in a box in some orderly way. There are four possibilities. One way to arrange the marble in orderly rows and sticks with the sphere in one layer sitting directly on top of those in the previous layer so that all layers are identical. So the arrangement is simple cubic packing in which each sphere is touched by six neighbors, four in its own layer, one above and one below, and is thus said to have a coordination number of 6 and occupy 52% of available volume. So one all the metal in the periodic table, only polonium crystallize in this way. So here is show that structure of simple cubic in which one atom in the center for another and one top of the atom and one below of the atom. So second is face center cubic packing. Alternatively, space could be used more efficiently if instead of sticking the sphere directly on top of one another, you slightly separate the sphere in a given layer and offset the alternating layer in an AB and BA layer. So here is the side show that the color of layer A and layer B. So in this arrangement called body center cubic packing, in each sphere has a coordination number of 8 for neighbor above and below 4, and space is used quite efficiently. 68% of the volume is occupied. Iron, sodium, and 14 other metal crystallize in this way. So here is side show that body center cubic structure, so in which one atom in the center, 4 above and 4 below of the atom, of the center atom. So third one is a hexagonal closest packing. The remaining two packing arrangement of sphere are both said to be closest packed. This packing arrangement has two alternating layer AB. Each layer has a hexagonal arrangement of touching sphere which are offset so that sphere in a layer fit to be in a layer B fit into the small triangular depression between this sphere uh, in an packed. So fourth one is closest packing. The cubic closest packing arrangement has three alternating A, B, and C. So the A B layer are identical to those in the hexagonal closest packed arrangement, but the third layer is offset from both A and B layer. So silver, copper, and 16 other metals crystallize with this arrangement. So here of show that cubic closest pack. Here is the color of A and like layer B and layer C. A face center cubic cell has 8 cornered atom plus an additional atom in the center of each of 6 faces that is shared with one another neighboring cube. Thus, one half of each face atom belong to a given unit cell. So in the side show that the structure of a center cubic unit cell. So there are half of face and 6 faces share on one another neighboring cell. So the face center cubic cell is the repeat unit found in the cubic closest pack, as can be seen by looking down in the body diagonal of a unit cell. The faces of unit cell cube at the 54.7 degree angle to the layer of the atom. The body center cubic unit cell has atom each of the eight corner of a cube like the cubic unit cell plus one atom in the center of the cube. Each of the corner atom is the corner of another cube, so the corner atom are shared among 8 unit cell. So it is very interesting structure of body center cubic unit cell in which one atom in the center and simply 8 corners show on the 8 corner 8 atom show simply. So in the primitive cubic unit cell, the atom are present only at the corner. Every atom at the corner is shared among 8 adjacent unit cell. There are 4 unit cell in the same layer and 4 in the upper layer, and therefore a particular unit cell on has the only 1/8 part of an atom. So here is show in the structure 8 adjacent unit cell. So hexagonal closest packing is the only one of fourth that has a non-cubic unit cell. So next one is topic types of crystalline solid. There are 4 major types of crystalline solid. Molecular first. Molecular solids are those like sucrose or ice whose constituent particle are molecule held together by the intermolecular forces. A crystal of ice, for instance, is composed of water molecule held together in a regular way by the hydrogen bonding. So second is covalent network solids. Covalent network solids are those like quartz or diamond whose atoms are linked together by covalent bond into a giant three-dimensional array. In effect, a covalent network solids is very large molecule. So third one is metallic solids. Metallic solids such as silver or iron also consist of large array of atoms, but their crystal have metallic properties such as electrical conductivity. So fourth one types is ionic solids. Ionic solid made of positive and negative ions and held together by electrostatic attraction. They are characterized by high melting point and brightness and a poor conductor in the solid state. An example of an ionic solid is table salt and ionic and sodium chloride. So it explained that the electricity easily pass through the sodium chloride and table salt. So simple ionic solids such as sodium chloride uh, and KBr are like metal in that the individual ions are spheres that pack together in a regular way. They differ from metal, however, in that the spheres are not the same size. Anions generally have large atomic radii than cations. As a result, ionic solid adopt a variety of different unit cells depending on size and charge of the ion. Sodium chloride and potassium chloride and a number of other salts have a face center cubic unit cell in which the larger chloride anion occupy corner and faces which the smaller sodium cation fit into the hole between the adjacent anions. So here is unit cell of sodium chloride. In the sodium chloride unit cell, for instance, there are 4 chloride anion, and here is the interesting structure: 8 particle on the 8 corner, and 1 atom in the center, and show the three. And next is 1 plus 1 over 2 and 6 equal to 3 faces of the atom on 3 atom show, and 4 sodium 4 sodium cations and 3 edges atom plus 1 in the center. 3 edges mean that 3 corner. Unit cell of copper chloride. Copper chloride has a face center cubic arrangement of the larger chloride anion with the smaller copper cation in the in hole, so that each is surrounded by tetrahedron of 4 anion. So in the above structure, chlorine or show by the blue color, and sodium by the red color show in the structure. So here is the structure of the copper and chloride. They are linked by the bond. So unit cell of barium chloride. Barium chloride by contrast has face center cubic arrangement. The smaller barium in which 2 electron remove and it become cation, with the larger chloride anions surrounded tetrahedrally. As required for charge neutrally, there are twice as many chloride ions as barium, 2 positive cations. So that's all from my side. Thank you so much. If you have any question, you can ask me in the comment section. So thank you so much.